And welcome back to the workshop. This is Tim for Tim Krause Electronics, and this is part 3 of our $75 Dumble build series. Now, if you haven't watched the first 2 parts, go back and watch that. That gives you all the background you need for this series. Got a lot done in the last video. We got the entire the core circuit board fully assembled, and now we need to start working on the sub-assembly boards. The JFET input board, the power supply for the 12 volts, relay board, the reverb and effects loop circuit board. I'm going to save that for the last. I want to make sure that the entire amp is working, and then once I know that I don't have any issues, then I'll build that board and tie everything into that. So the first one I want to work on is that input board, so I'm going to go ahead and get started on that. Alright, I'm going to go ahead and assemble the input board with the JFET boost stage. And I've planned out the layout here and printed that out. The transistor that we're using to switch in and out the source bypass capacitor, which is going to be what's giving us gain in this input stage, is going to be a BS170 because MOSFETs have a lower on resistance than bipolar transistors do. However, the BS170 comes in 2 different pinouts. So you got to be careful which one you've got. Anyway, I've put together the circuit on a breadboard just to make sure that it works, and I've got the right orientation for this transistor, and I'm using an LED as a stand-in for that source bypass capacitor. So when I touch this lead to ground, you can see it turns, well, I don't know if you can see that or not, but there we go. LED turns on and off. So I know I've got the orientation correct there, and I'm going to go ahead and start assembling this. These J201s are fairly heat sensitive, so I'm going to use a socket here just to be on the safe side. And that's not going to stay in by itself, is it? Nope. Okay, so what I do when I have stuff like that just doesn't want to stay in, usually I put a little bead of solder on the pad there. Find my spot here, and then I'll line it up with the pad and just reflow that solder long enough for it to pop in there. There we go. Now it'll stay in place. And here's our source bypass capacitor. I'm using a 4.7 microfarad. Now, this last transistor I'm putting in here is the BS170 MOSFET, and it's also somewhat temperature sensitive, so I have to be quick when I'm soldering this. I like to do as much testing as I can along the way so that I don't end up putting the whole thing together and then spending hours tracing down where a problem is. So I want to make sure that this works before I install it in the amplifier, which means I've got to give it some power. So I've got this 9-volt battery pigtail with a disconnect on it. I use this when I'm breadboarding stuff. So I'm going to solder, just temporarily solder this other end of a disconnect on here so that I can plug it in and put some power to this board. And then I'm also going to solder in an input jack and output jack. And then I'll plug everything into a working amplifier. And that just gives me a chance to make sure that everything's functioning properly. And here's our boost gain pot. And finally our switch. This is what's actually going to activate the FET boost stage. While I'm at it, I'm going to attach a piece of this zip wire. The foot switch is actually in parallel with this front panel switch, so that if you have either the foot switch engaged or the front panel engaged, either one will turn on the boost. And I've got a really long piece of wire here. I'm leaving it intentionally long because I'm not sure yet where this where the foot switch jack is going to be mounted. Okay, so here's our input board. This is the pot, the switch, and then I've got a jack connected to the input and one to the output running out to my amplifier. It's a good thing that I socketed this JFET because it turns out, well, there are two things actually that were problematic. The first was that I had the pinout wrong, so I had it installed backwards. So because I had it socketed, I was able to just flip it around. And the second thing is the J201 didn't have enough gain. I also had some 2N5458s around, and I thought the J201 had more gain than that. But the 2N5458 actually has quite a bit more gain than the J201. And maybe it's just because JFETs vary so much. You know, if I were to go through the whole drawer of J201s, I'd probably find several that were really high gain and several that were really low gain, and maybe I just grabbed a low gain one. But the 5458 that I've got in here gives me plenty of gain, so I'm just going to stick with that. But anyway, here's my guitar straight into the amp. The boost is not engaged. And then as I engage this boost switch, you'll hear a little bit of a jump in gain. The knob is all the way down right now. So here's the switch off again and on. So a little bit of a boost, but then as I turn this control all the way up, so that's given me plenty of gain. So let's go ahead and install this in the chassis now. Well, I had to switch pots. This is the pot that I had on there originally, and as you can see, it's quite a bit bigger than the pot that I'm going to end up using. The reason for that is that once this input jack goes in here, there's not enough room for the larger pot. And really, you don't get any benefit from these larger pots. The only difference is that the larger ones can handle a little bit more power. But, you know, these are small signals that we're dealing with, so any pot will be fine. So I've installed a shielded cable here. This is what's going to be coming out of our boost and going into the grid of the first valve. The cable, the wires coming off of the jack are not shielded, but in this case I don't need to shield them because the wire is actually going to be tucked back into the corner away from everything else, so there's really no chance of any interference there. Now the way that I'm going to attach this to the chassis is with some of this double-backed foam tape. And it's another one of those things, it's not ideal. I would rather be able to use standoffs and actually screw it to the chassis, but in this case, if I were to use standoffs, this would sit a little too close to the main circuit board, and I don't want to risk causing any interference because of the proximity there. So this tape will stick pretty well. There is really no danger of this coming undone. I'm going to clean the chassis really well with some alcohol and a shop rag, and you have to be careful when you're mounting things this way. I actually repaired a pedal. It was a commercial pedal, and they basically bought a kit from one of those well-known websites and put together the kit and then sold it as their own product. And the way that they attached their circuit board was with some double-backed foam tape, just like this. But they didn't line the back of the circuit board with anything, so where the ends of the leads were poking through, it actually ended up poking right through the tape and shorting out on the chassis. So in this case, what I've done is I've spread some hot glue out all over the back of this, and then before it cooled, I pressed it down onto the chassis to make sure that I had a nice flat surface. That gives me the extra distance that I need to make sure that none of these leads are going to end up shorting against the chassis. Okay, so that's nice and secure now. That's not going to go anywhere. Okay, so now the input board is installed. I put a couple extra terminal strips in here. I'm going to be using those to connect a couple components straight to the socket pins. And I still haven't installed the power tube socket, so I'm going to go ahead and rivet those in place now. And then, now that I've got these terminal strips here, I know exactly how much room I've got to work with, so I can start working on the power supply board for the DC on the first two filaments, and everything else that's going to be powered off of the 12-volt DC. Okay, now it's time to start putting together the relay board, and I've got a few of these 12-volt relays, fortunately. These are also left over from a previous build inside this Valveking chassis. So let's put this together. Now, anytime you're working with relays, you have to use a flyback diode. Because of the inductive nature of the coil, it can build up some very, very high voltages on there in the thousands of volts, so it can be really dangerous. So always use a flyback diode. You don't have to use a slowdown capacitor. In some cases, you're not going to get a pop from your circuit whether you use a capacitor in there or not, but you always have to use a diode. This is the slowdown capacitor that I'm using here. It's just a 0.1 microfarad ceramic cap. And I probably don't need to use one. Dumble didn't use one in his amps as far as I know. But just to be on the safe side, I'm going to put these on here. Okay, there were a few more things that I needed to do, and you know, some things are just a lot easier to do if I don't have to worry about the camera, and you know, it's stuff that's really not interesting anyway. So without recording, I went ahead and mounted all of the pots on here, and I also changed the originally what I was going to do was I was going to have the effects loop jacks mounted on the back panel. Like you see in most amplifiers. Peavey had them mounted on the front panel. And originally I was going to have all the pots mounted on the front panel, which would have taken up, I would have ended up using these two holes for the effects loop jacks for pots, which wouldn't have been great because the holes are a little larger than they need to be, so it would have been kind of sloppy sitting in there. And so I decided to just mount the effects loop jacks on the front panel like Peavey did it. And I think it's a little more convenient that way. Because, I mean, if you think about it, when you're plugging your effects into your amplifier, it's a lot easier to plug them into the front of the amp than, you know, than do it in the back. You know, same thing with the power switch. Whenever I can, I like to put the power switch on the front panel of the amplifier instead of the back. I'll do it on the back panel. I have done it on a few amp builds. But usually just because I run out of room on the front panel and I don't have any other choice. So I think I'm going to like having the effects loop jacks on the front panel, but that means that I don't have room for all of the pots. So what I'm going to do is the overdrive trim control, which is normally a trim pot on the circuit board in Dumble amplifiers, I'm going to move that to the back panel. The fact that most builds have their OD trim control on the circuit board tells me that I'm probably not going to be tweaking that control a whole lot, so it's not a big deal to have it on the back panel. I've also mounted the bias pot on the back panel here, and I've cut the DC power supply board down to size, and I've got some holes drilled here. Did the same thing with the relay board, so I'm ready to go ahead and mount those on the standoffs. Actually, I don't have the standoffs yet for this power supply board, but I'll get those in here shortly. One other thing I wanted to show you here, and you can ignore these labels here. These labels are left over from the last build in this chassis, so I just haven't removed those yet. But these 3 LEDs here are indicators for the channel. So when I'm on the lead channel, this will light up blue. When I've got the mid boost on, this switch here, then that'll light up green. And then when I've got the FET input boost active, then that'll light up red. And right here you can see the back side of these 3 LEDs. Obviously those are too long right now, so I'm going to have to trim those down, and I'll solder some wires onto those, because those are going to come up onto this circuit board. And I've got an extra resistor on here so that when we turn on the transistor that turns on these relays, it'll also turn on the LED. Now, I don't have a lot of wire inventory, which is why a lot of times you'll see me using white for almost everything, and it does make it kind of difficult to keep track of what's what. But in this case, for these LEDs, I happen to have a little bit of Cat5 cable. And the Cat5 cable comes with the twisted pair of orange, orange-white, green, green-white, blue, blue-white, and brown, brown-white. So I can use these to wire up those LEDs. Then I'll have a much easier time telling them apart. You know, these are already tightly twisted, so that's a good thing too. I just want to reiterate how we're doing the switching on this so you can understand how I'm tying in the LEDs. This NPN transistor, which I'm using a 2N5088, but it can be just about any transistor, this is actually turning on and off our relay or whatever else the load is. So when we apply a voltage to the base of this transistor, it pulls it high, pulls the transistor into saturation, allowing current to flow through the transistor, and it saturates to a fairly low resistance. And then when we take that voltage away, it goes into cutoff, because this reference resistor here, which is tied into ground, and this is 100K that I'm using, it's tying it into ground, that's just kind of, it's keeping it so that instead of just the base kind of floating wherever, it's pulling it down to ground when the voltage is not being applied. So it pulls that transistor into cutoff, and so there's no current flowing through here, and the resistance across this transistor is, for our purposes, we can think of it as infinitely high. I mean, it's completely closed, or opening the switch here. So the reason that we're able to power an LED directly off of this instead of having to use a separate transistor is because when we tie the base of this PNP transistor to ground, it allows current to flow through here. So this 12 volts is coming through this transistor in order to pull this base high. So that means we've got 12 volts available right here. So all we have to do is take a wire off of this point and bring it up to our LED, and then we'll have to have a current limiting resistor there, and then tie that into ground. But now every time that we touch the base of this PNP transistor to ground, it's going to turn that LED on, and it's going to allow current to flow through this transistor. Now apparently I wasn't very smart about this when I installed this board, because I have a resistor on here, a current limiting resistor for the red LED that's going to be our indicator for when the boost is engaged. But I didn't wire I didn't solder a wire on there, so now I've got to somehow get my soldering iron in there without melting any of these other wires, so this is going to be a tricky one. Also, while I'm at it, I'm going to go ahead and take these 4 pots out of here because what I want to be able to do is get a hot glue gun in here where these LEDs mount, and then I'll just put a little bit of hot glue to keep them in these LED bezels because they're not the greatest LED bezels, and I want to make sure that they're held securely. Okay, now I can route this wire over here and tie it in. This is the one that's going to be really tricky because it's right behind this wire. Let me see if I can move this out of the way. Yeah, I wasn't too smart about this. And I know you can't see what I'm doing right now. I can't either. There we go. And I got a couple extra holes here in the chassis, so I'm going to pass a zip tie up through there and tie this wire down because it's going right past the input jack and I don't want to risk it kind of creeping up on it and causing interference. Although it probably wouldn't be an issue because there's so little current. Now, these other 2 pairs are going to be coming over to our relay board, and I'm not quite ready to tie those in yet because I'm going to have some shielded wire going into the relay here. So I don't want to end up tying the relay board down and making it more difficult later on to do the work I need to do. So what I'm going to do is just bundle these wires up just to get them out of the way, and then later on when we're ready we can tie those in. Alright, the next thing I've got to do before I can go any further is wire up these filaments. Problem is I don't remember which one of these secondaries is the filament winding, so I'm going to have to take some voltage measurements off of here. So I'll plug this in for a minute and hope I don't blow myself up. 358 volts on the red wires. So these are the high voltage, these red wires are the high voltage, which is what I thought, and I'm just going to tie them up here with some tape and put a little label on here, HT, so I know what those are. And I'll check the orange ones next. So one of these pairs is the filament winding, the other one is the bias winding. And I just realized I'm going to have to redo that the rectifier board because I didn't wire that as a bridge rectifier, and there's no center tap on this HT winding. Okay, so the orange wires are giving me 18.8 volts. That seems a little high. I don't know. Anyway, we'll see what the other one is. These are probably the bias winding. Yeah, 80 volts. So this is our bias winding. Okay, the heater pins on a 6L6 are 2 and 7. But remember, we've got to wire these heaters in parallel because this is twice the voltage that we want to have for the heaters. So one of these wires is going to go into pin 7 of this first socket here, and then the other one has to go all the way over to pin 2 of the second socket. And as you can see, this wire is not long enough, so I'm going to have to cut this and splice on a little bit of extra wire to bring it over to here. And then from pin 2 of this socket to pin 7 of this socket, we'll have just a direct connection across here. And this is 18 gauge wire that I'm tying into this. Okay, so the second side of this will go on to pin 2 here, tied into pin 7 on the next tube. Okay, so now this 18 gauge twisted pair is going to be tied into our DC power supply board over here. And once again, I'm going to make use of this extra hole here and tie this wire down because we're going to have a circuit board right over top of this. Alright, I've got some holes drilled for the standoffs for this 12 volt power supply board, so I'm going to go ahead and install this. And this chassis is starting to look like Swiss cheese, but there just weren't, the holes were in there weren't close enough to what I needed, so I had to drill more. Oh well. Okay, so these wires are going to be tied into this rectifier here, this bridge rectifier chip. I'm not going to tie those in yet because we've still got other power wires that have to come into this board that are going to be feeding the relay board and the input, the FET boost stage. So I'm going to leave that. I'm going to leave these wires hanging there for now. Alright, we got a couple more things mounted, a couple more things wired up here. So we're making good progress. I'm going to stop there for today, but I wanted to talk about a couple of things before I finish this up. First of all, the rivets that are holding the power tube sockets in place, I'm going to have to drill those out and put some screws in there instead because the slot on the power tube base, on the base of the socket, is too big, and those rivets are it's not holding them securely, so I'll have to use some bolts. I like using rivets because I know that over time they're not going to loosen, so I'll probably just put some Loctite on there and it'll be fine. Second thing was the choke. I ended up installing the choke here, and initially I wasn't sure if 50 milliamps was enough for this amplifier because I couldn't find any data on how much current the power tube screens pull. Turns out they pull about 5 to 10 milliamps. So, and then the power tube plates are all going to be drawing, probably just over 2 milliamps. So call it 3. That's at most 20 milliamps from the screens, and then another 12 for the preamp plates. So we're at 32 milliamps. So that 50 milliamp choke is plenty. Last thing is, in the last video I was talking about those, what brand are those again? The Dale Vichy metal film resistors. Another thing that I found out about those, I looked at the data sheet again, and apparently they're lower noise than a typical metal film resistor. So that's probably another big reason why a lot of people like to use those. They're very, very low noise resistors. In my experience, any metal film plate resistor is going to be quiet enough. It's up to you if you want to spend the extra money to get those Dale Vichy resistors. I imagine if you use them throughout the entire amplifier, you probably have noticeably less noise from the resistors. Maybe that's something I could try in the future. But at this point, I still think just a regular blue metal film resistor is going to be good enough. Especially in an amplifier that's not like, if you were building something with 8 gain stages in the preamp and it was just, super, super high gain, then you probably would want to go with something like that just to keep the noise down. But in this case, we've got DC on the first 2 tubes. That alone is probably going to improve the noise floor pretty significantly. So anyway, that's where we're going to stop today. In the next video, I got to tie in all the power wires to that power supply board. I'm a little concerned at this point by the voltage that I measured on the secondary for that 12 volt supply, because I measured, I think I said 18 volts, and that seems kind of high to me. So I'm hoping that comes down once it's got a little bit of a load on it. Otherwise, that's just going to end up being way too much voltage for those 12 volt relays. So we'll have to see. I guess once I've got everything tied in, I'll take another measurement, and before I switch on the relays, I'll make sure that it's not too high. Anyway, that's it for today. Like it if you like it, comment and subscribe, and we'll see you in the next video.